Hi everybody, happy Friday. So today you have homework 2 about session 1.4 to 2.2. Okay everybody? So today you have a quiz. The quiz is online, right, in Blackboard. So remember, you just need to submit one picture, okay? So you don't have to convert into a PDF because it's only one page. So you just submit the picture. So you should be able to see quiz 2 on your Blackboard. And then you click quiz 2 and start. Then once you click this link, you can see the quiz questions. Okay? And then after you finish, take a picture and then you browse local files to upload your picture and then hit submit. And if your window closed before you submit, you open a second attempt right away and submit. Okay, everybody? So I set the number of attempts to be unlimited. So you can open attempts and submit. But if you use more than one attempt, just email me and kind of like tell me what's going on. So maybe your Wi-Fi is not stable or your upload your computer is slow. So but just send me an email, okay? So I know you used more than one attempt. Okay, so that's your quiz. And so today we will talk about session 3.1. We're a little bit behind schedule. It's okay. All right, so let's see. Okay, so all right. 3.1 complex numbers. Okay. All right, complex numbers. So you still remember natural number one, they're like 1, 2, 3, etc., right? And then the set of integers like -2, -1, 0, 1, 2, etc. Right? Do you know about natural number, integer? And then we have rational numbers. Rational numbers are in the form of P over Q, such that P and Q are integers. And Q is not 0. Right, everybody? That's rational numbers. And who's the bigger one? What's the next set of numbers bigger than irrational numbers? Yeah, irrational numbers and rational numbers together give us real numbers, right? The real numbers. And the one bigger than real numbers is the complex numbers. So complex numbers are in the form of a plus bi, such that a and b are real numbers. Okay, and I is the square root of -1. So we work with real numbers, we say we cannot have negative number in the square root, right, everybody? Because the graph of square root of x is what? What's the graph of square root of x? Like that? Yeah, like that, right, yeah, like that. So the domain is greater or equal to 0. So if we have negative number inside the square root, no real solution. Right, everybody? Okay, so today we talk about complex numbers. So we allow -1 to be in the square roots. This will give us I. So I is the imaginary number. Okay? So you imagine number and complex numbers. So a complex number in the form of a plus bi, where a is called the real parts of the complex number because it does not have the I with it, right? So a is the real part, and b is the imaginary parts of the complex number. Okay, and if b equals to 0, then you just get a plus 0 times I is just a. So you get a real number, right? And if a is 0 and b is not equal to 0, then the complex number is called an imaginary number. Okay, imaginary number. An imaginary number is an even root of a negative number, right? Okay. So this is the definition of complex numbers. So if you have complex number, you have the real parts and the imaginary parts. You can think of the real part as like the constant, and you have the 2i. The 2 is like the coefficient of I, right? You have letter I there. So the 2i is imaginary parts. And then this like the constant is the real parts. Okay, everybody? Example 1. Express this in the standard form. So this is the standard form. Some number plus some number times I. We want to express square root of 54 in the standard form. Okay. Here I want to keep in mind that square root of a times b is square root of a times square root of b. This is the rule. Everybody okay? Be careful. Square root of a plus b. Is this equal to square root of a plus square root of b? No, this is not true. Don't ever do that, okay? When you have square root of a sum, you cannot split them. How about a difference? Is it equals to square root of a minus square root of b? No. How about division? Is it equals to square root of a over square root of b? Yes. So for multiplication and division, we can distribute the square roots. But for sum and difference, can we distribute the square roots? No. Okay, so write down those rules. Okay. All right, now let's see. So we want to simplify it. Negative 54. For sure, I know it has a negative 1 there, right? What is 54? What can you think of? 9 times 6. Right, everybody? It's 9 times 6. Okay, good. Now we can distribute the square roots. So, and 9 times 6 is good factorization because you know what square root of 9? 3, yes? And square root of 6, can we simplify further? No, right? 6 is like 2 times 3. Oh, yeah. But 2 times 3, you don't have a square there. Unlike like 25, 25 is 5 squared, so you can simplify further. 16, what's 16? 4 squared, you can simplify further. But 6, you cannot simplify further. Just leave it like that. So therefore, this is square root of minus 1 times square root of 9 times square root of 6. What's square root of minus 1? Square root of 9, 3. And square root of 6 is square root of 6. Okay? So therefore, usually people write 3 square root of 6, and they like to put the I at the end. This is what we'll be doing. Put the I at the end. So this is the standard. 3.1. Yeah, 3.1. So last time we finished at 2.1 to 2.3. So today is 3.1. Complex numbers. Right, everybody? Okay, let's continue. Okay. Plotting a complex numbers on the complex plane. So here we have the complex plane, and the horizontal axis is the real parts. Attendance. Oops. Okay, I pressed the wrong button, so it will ring again after 9 minutes. Okay, so this is the complex plane. You know, a plus bi. On the complex plane, it has the coordinate a comma b. A is the real parts. Okay, So the horizontal axis is your real part. The vertical axis is your imaginary part. That's why, can you tell me what is this number? What's the coordinate of the point?
3,
Yeah, 3, -4. So it corresponds to 3 minus 4i. Is that okay, everybody? Can you plot the points -2 plus 7i? How can you plot this point? You do -2 and go up to 7. I know, this is 6, so 7 might be here. So the point is here. Right? So we have the xy. Yeah. The order pair, it corresponds to a complex number. This is the complex number. Okay? The first coordinate is the real part. The second coordinate is the imaginary part. That's why -2 is like the point minus, so it corresponds to -2, 7. So -2 is here, and you go up to 7. This is the point. Is that okay, everybody? Oh, I just make it up and ask you where is this point? Yeah. Now I make it up and ask you, okay, where is -5 minus 3i? -5, and then you go here, down 3. Exactly. So this is the point.
So it's basically just the point where you add an I.
Yes. Right. This is the complex number. So this is the complex plane. Okay? Complex plane. So yeah, that's why sometimes people can say complex plane. It looks like R2. Because you can find a 1-to-1 correspondence between a complex number and the order pair in R2. Yes. Okay, next. Operations. How do we add or subtract complex numbers? Well, it's like how you add expression with x. You add the like terms. Or you add the constant terms together. You add the linear, like the x power together, right? Add the like terms. So you add a constant, add the coefficient of the I, or you subtract the constants, you subtract the coefficient of I. Okay, so everybody, example 2. Can you do example 2? I want you to do example 2. So everybody do example 2. You have that one?
This one?
3.1. Yes, this one. Second page. Try to add them. Yes, add them. Add the like terms. Add the like terms. Yeah, of course. So here is the node answer, and this is the one. X plus I. Yeah, exactly. It's just like X.
Because I ran around.
Yeah, right. It's just like X. You call it I. It works the same. Exactly. Right? Good. Okay. Good. All right. So because you addition, you add the like terms. So 3 plus 2 is 5, and plus I. Do you all get that, everybody? Combine the like terms? Okay. Like parentheses, like here? Like here? Oh, you can put them in parentheses, but I'm just saying your final answer will be the same. Okay. How about let's do subtraction? If you do 3 minus 4i, subtract 2 plus 5i, what do you get? Okay, so the first parentheses, we can actually ignore it, right? The second parentheses, what do? Distribute, then you get? Yes. And what is the constant term? 1 and minus 9i. Yes.
Why is the 5? Can you like why is that changed to negative?
Oh, because of minus sign. Distribute. Right.
You don't have to do like that. It's just
We distribute. So we get minus 5i.
because you can just take away minus five, two words and subtract five.
Distribute. We get rid of the parentheses first.
Oh.
So let's distribute. With the parentheses, we cannot add or subtract anything. Right? We have to get rid of the parentheses. Then we can add the like terms together. Okay. Let's do more exercise. Okay. Let me put a more example here. How about let's do 4 times 2 minus 3i minus 3 times 5 plus 7i. What do you do with this?
Distribute first.
Distribute. Everybody do it. Okay, do it.
Wait, where are we at?
Oh, that one. I just make it like that. Please.
So I just finished this.
Oh, okay. No, that one. Oh, no, not this one. That one.
Oh, then okay.
Oh, we didn't get that number yet. I'm making a harder one.
Oh, okay.
Oh, yes. So 3 plus 2 is 6. And
What about the? Oh,
minus
I
4
thought
plus
you
5 is I.
Yeah.
1 times I is 1.
Cold water. Yeah.
So the way how you do it is just like arrows in the lecture.
Really?
By the lecture. Or you treat the I as
I live
like
right
this.
around there. Yeah.
Oh yes, it rang again. Okay, stop.
Oh.
Okay, ready to check your work? When you distribute, what do you get?
8 times 12i minus 15 minus 21i.
Good. Now you combine the like terms. What's 8 minus 15? And minus 12i minus 21i is? Yeah, very good. Okay, awesome. Okay, now let's multiply complex numbers together. So you use the rule that, I is square root of minus 1, then I square will be minus 1. So you use this rule. Okay. Now let's multiply them. Okay, so multiply the 4 first. What's 4 times 2? 8. Bless you. 4 times negative 5i.
Wait, what is it?
Oh, 4 times negative 5i. Negative 20i. And then we look at the 3, right? 3i times 2.
Plus 6i.
3i times negative 5i. Yes.
So then you would just multiply the negative 15 by the negative 1.
Exactly. Very good. So this is negative 1. So we multiply the 15 and negative 1. It becomes positive 15. So let's rewrite it. So positive 15. Good. Yeah, once you do that, you can combine the like terms.
23 minus 14.
Yeah, 23 minus 14i. Right, everybody? Mm-hmm. Good. So, actually, I is square root of minus 1. I square is minus 1. And you can keep going. So, you get I cube is like I squared times I. Do you agree? And replace I squared by minus 1. So you get minus 1 times I is minus I. And I to the 4th is actually I squared times I squared. Do you agree? And then minus 1 times minus 1 is 1. Oh. And then when you keep going, I to the 5th is I to the 4th times I. Do you agree? I to the 4th is 1. So you get I. So I, the power of I, will get into a circle. Okay? I is this. I squared is minus 1. I cubed is minus I to the 4th is 1. I to the 5th, you get back to I. I to the 6th will be like I squared. I to the 7th will be like I cubed is minus I. I to the 8th, 1. I to the 9th, go back. You see that circle? It's just a pattern of 4. So if you understand the pattern, then you can conclude that actually I to the power 4k plus 1 looks like this. K is any integer. Okay, for example, if I plug in k is 0, you just get 1, right? If I plug in k is 1, you get, if k is 1, you get 5. If I plug in k is 2, you get 9. See? You see this pattern? And then for the second one is I to the 4k plus 2. It equals to minus 1. And I to the 4k plus 3 equals to minus I. And I to the 4k, you don't need to put plus 4, because 4k and 4k plus 4 is kind of the same thing. You just let k be any integer. So now my question is, what's this year? This year is 2023. What is this equal to?
It'd be a high. Wait, no. Negative. Yeah.
Yes.
Exactly.
Negative I. Because 2023 divided by 4, what do you get? 5, right? And then the 2, not enough. 3, you need the 5. Your remainder is 3. So this is like I to the 4 times 505 plus 3. So it's like this type. So you look at the remainder and then you can see. Okay, everybody? How about next year? Next year is 1. Okay, everybody? So those are the powers of I. Okay, good. Let's keep going. Oh, sure. Okay, sure. This is the I patterns. Alright. Okay, and next, how do we divide complex numbers? Okay, so let's do this example. 2 plus 5i, and we divide it by 4 minus I. When you divide it by a complex numbers, you multiply the conjugates of the denominator. The complex conjugates is found by changing the sign of the imaginary parts of the complex number. So the real parts is still the same. In other words, the complex conjugate of a plus bi is a minus bi. Okay? So far, so good. That's complex conjugate. Have you heard conjugate before? Okay, no. All right. So complex conjugate is the real parts stay the same. The imaginary parts flip the sign. Okay? You can think of this way. You have this point. This point is a plus bi. And then the complex conjugate is kind of like you flip it over the x-axis, so it becomes a minus bi. Okay? So this is like the lake. You're looking at your reflection of the lake. This is a complex conjugate. Alright. So how do we divide numbers, complex numbers? We multiply, okay, multiply by the complex conjugate of the denominator. Okay, and you multiply the top and bottom, so let's say top and bottom by this. Okay, so in this problem, we multiply the top and bottom by the complex conjugate of the denominator. What's the complex conjugate of the denominator? 4 plus I, exactly. So 4 plus I and 4 plus I. Bless you. Okay, let's put parentheses around them. The reason why we want to multiply by the complex conjugate of the denominator is to get rid of the I in the denominator. We don't want to see any I in the denominator. That is our goal. Okay? The good thing about the complex conjugates is, you remember that formula a plus b times a minus b? That's what? A squared minus 2ab is this one. AB, just b squared. Okay. Yeah, write down all the formula. If sometimes you get confused, write them all out. Okay. And if you have minus, then you put the minus there. Okay. So we make use of that. Okay. Now let's see. Look at your numerator. Numerator, you distribute, right? What's 2 times 4? 8. 2 times I, 2i. 5i times 4. 5i times I. 5i squared. Is that okay, everybody? We multiply the numerator. Look at your denominator. See, we're using this group. What does that equal to?
16.
Yes, good. So 4 squared minus I squared. If we just use the root directly, right? Because a plus b, my a is like 4, my b is like I, right? So that equals to a squared, which is 4 squared, and then minus b squared, which is I squared. And the good thing about I squared is it equals to -1. The carry of I in the denominator. Exactly. I mean, 16 minus -1. So 16 plus 1. Right, everybody? Yeah. So, okay. Let's simplify this. 16 minus -1 is 16 plus 1 is 17. 17. Look at your numerator. What's I squared? -1. So this becomes -5. Right, everybody? So combine the like terms. Yes. A minus 5 is 3. How many I? 22I. And usually we like to separate the real parts and the imaginary parts. So you would put 3 over 17 plus 22 over 17I. Yes, we always separate them. Because you want to make sure what is the real part and what is the imaginary part. So that's why usually people split them. So I would prefer to have this, but if you have this in the Excel, I would think about it when we're using concept. So. Okay. All right. Let's see. Okay. Before we get into the next example, I want you to do more exercise. How about everybody do? Let me just make up something. Okay, so 7 minus 3I divided by 2 plus 5I. Okay, do that. So on a piece of paper or if you have some room somewhere on your worksheet, do this. Multiply the top amount by the composite conjugate of the denominator. Okay? Because we want to get rid of the I in the denominator. We know there will be I in the numerator. So numerator is okay, but denominator we don't want to see. Minus 5I, yes, we multiply top and bottom.
Times 7 plus.
Oh, your numerator remain the same. So we multiply this whole thing by the composite conjugate of the denominator. But don't change to 7 plus 3I. So only the composite conjugate of the denominator. So what is that?
2 minus 5.
Yes. So multiply by 2 minus 5I. Yes. Oh, yeah, you have a square and you have a square.
Oh, yeah, I was doing this right. Oh,
Okay,
but
is it plus or
as long as we're passive.
7 times 2. Okay, 7 times negative is minus 1.
If
And
you were,
then this
if
one
you're
is
passive
minus
before the light is red,
Oh, no, yeah, but 2 times negative.
I know obviously.
And then minus becomes
So, because I know that.
right, have a denominator. And 5 times 5 is.
No.
Okay, everybody, cut over together. So 7 times 2 is 14. 7 times minus 5i.
Minus 35i.
Minus 3i times 2. 96i. Minus 3i times minus 5i.
Plus 15i squared.
I squared is negative 1. So this is negative 15. Yeah. So this is negative 15. So sometimes we are lazy. We don't want to write down the whole thing again. Just put this guy equals to negative 15. Okay. Denominator, what? 2 squared minus 5i parentheses square. Right, everybody? Okay, numerator, 14 minus 15. Minus 1. How many I?
41.
41i. 2 squared. 4. 5 squared. 25. And I squared is negative 1. It becomes positive. And I can tell you the truth, this middle side is always positive. Okay? Because it's minus b squared, but the I squared give you minus 1. So it will always get plus. Okay? Yeah. Alright. What's 4 plus 25? 29. So split them. Minus 1 over 29 minus 41 over 29i. So this is the final answer. Okay. Alright. Good. Let's keep going. Example 5. Now we have functions on complex numbers. Okay, it's not functions on real numbers only. We have complex numbers. We plug in x equals to 3 plus I. That means whenever you see x, replace x by 3 plus I. Okay, everybody? So let's do that. Do you see x squared? So replace x by 3 plus I squared minus 5 times x. What's x? 3 plus I. And then plus 2. Right, everybody? Yes. Okay. What is 3 plus I squared? Look at the formula. What's a plus b squared? So 3 plus I squared is? Yes. Good. Let me write down I squared first, then we know this is minus 1. Is everybody okay with that? We're using this formula. With A is 3 and B is I. So that equals 3 squared. 3 squared is 9. Plus 2 times 3 times I. 2 times 3 is 6. 6I. Plus B squared. B is I. So I squared. which is minus 1. Is that okay, everybody? Yes? Okay. Continue. Bless you. Distribute. What do you get? And then minus 5i plus 2. Okay. What is the constant term? 9 minus 1 is 8. 8 minus 15. -7 plus 2. -5. Is everybody okay with that? -5. Okay. Where the I term? 6i and 5 minus 5i is I. Ooh. So our answer is -5 plus I. Okay, everybody? So for power function, you just multiply more power. But if they give you x cubed, what do? Well, if they give you x cubed, then you know x cubed is x squared times x, right? So you have this 9 plus 6i plus I squared is -1, right? So it's actually 8 plus 6i. We agree? And then that one multiplied by x again, 3 plus I. So then you distribute, get 4 terms instead. So this is when you have x cubed. X cubed is x squared times x. So this is square. Square is 9 minus 1, so 8 plus 6i. And you multiply by one more copy of it. Then you have to expand it. Is that okay, everybody? Mm-hmm. All right, keep going. What happens if we have a rational function? Let's plug in. So f of 4i minus 1 equals 2 plus x. What is x? 4i minus 1. Actually, here I can put a parentheses or I don't put a parentheses. It's the same thing because there's addition in front of it. But if you have like 2 minus x, then you have to put a parentheses around it because there's subtraction in front of that. Okay, just be careful. Denominator x. X is 4 minus 1. Because it's addition, so we cannot cancel. Remember, a plus b, a plus c, we cannot cancel. No, so this is not equal to b over c. Cannot do that. But if you have multiplication, yes, you can cancel. But addition, you cannot cancel. All right, so x minus 3, right? Okay, numerator, because it's plus, so we don't need parentheses, right? So it's okay to not write a parentheses. What's the constant term in the numerator? -1 or +1? +1, yes. And then plus 4i, right? Denominator, -4 plus 4i, right, everybody? Question, can we cancel the 4i? No, we cannot cancel the 4i. So now simplify means you want to get rid of the I in the denominator. Okay? Here, I'm gonna teach you a trick. So if we want to use the rules we had before, you want to multiply by the conjugate of this, which is -4 minus 4i. Do you agree? Conjugate is like you change the middle number to from plus to minus. But I can tell you this number is so big. Actually, this problem, you can simplify the process a little bit. Can you see the denominator? You have a common factor, 4. Yeah. Let's factor out the 4. Okay. Can you see I also have a negative here? So I can also factor out negative. So let's factor out negative 4. So we factor out negative 4. What's left?
1.
And then? 1 minus I. Do you agree, everybody? We factor out minus 4. We get 1 minus I. Yes? Because when you distribute, minus 4 times 1 is minus 4. Minus 4 times minus I become positive 4I. Oh, how nice. See, this minus 4 is already a real number. Do you agree? So we just need to get rid of the I here. So we want to get rid of this I. We multiply it by the conjugate of that. The conjugate of that is what? 1 plus I. Yes, everybody? Look at the calculation. You only need to multiply by 1 plus I. Do you want to multiply by minus 4I? I look at the negative, I get easy. So this is much easier. Okay, so it makes your calculation much easier. So just do some factoring if you see some common factor downstairs. Okay. All right, let's do that. Okay. So we have minus 4 is still a factor, right? Look at the numerator. 1 times 1 is 1. 1 times I is I. 4I times 1, 4I. 4I times I, 4I squared. What is 4I squared? This is negative 4. Is that okay, everybody? I'm doing this because I'm lazy. I don't need to write the whole thing again. But up to you. If you don't mind to write on the whole thing again, feel free to do one more step. Okay, if that's more clear to you. Okay, next, denominator. What is 1 minus I times 1 plus I? It's 1 square minus I square. Are you all familiar with the formula? A plus B times A minus B is A squared minus B squared. So 1 squared minus I squared. What's I squared? Negative 1. So minus 1 is 1. 1 plus 1 is 2. So this phase is actually 1 minus negative 1. So it's 1 plus 1. So it's 2. Okay? Alright. Look at the numerator. Numerator 1 minus 4 is 1 minus 4. Negative 3. How many I? 5I. Yes, everybody? Denominator. What's minus 4 times 2? Negative 8. See, split them. Negative 3 over negative 8 plus 5 over negative 8I. Can you cancel the negative? Yes. 3 over 8. Can you move the negative in front? Yes. 5 over 8I. So that finished the problem. Okay, so this tells us that if you can factor something in the denominator, do that first. Imagine if you have the 4, oh my god, the number would be so big. And you need to do some cancellation factoring later. So you would have the same. Oh.
Because I started doing it, it's just so much 16s I messed up somewhere. So.
Oh, okay. Yeah. It's easy to work with smaller numbers. Okay, everybody? All right, good. So that is how we divide complex numbers. So actually, multiply powers of I. We already talked about that, right? We have the pattern. After 4 times, we get it back. So, okay, now you do. What is I to the 35? Now you divide, and you find the remainder. How do you do? How do you divide? Oh, sure. Yes. Right, yeah. Negative I brains. Okay. Yeah, everybody take notes. So write it down. 35 divided by 4. What do you put in the quotient? 8. 8 times 4 is 32. And then you use 35 minus 32 is 3. So I to the 35 equals I cube. I cube is minus I. Okay, everybody? Just look at the remainder. So, yes, look at the remainder and then put it here. So far, so good, everybody? Okay, good. Ooh, this one is example 8. I would say example 8 is harder. Okay, how do we do example 8? We have two fractions, right? First of all, those two fractions, you want to get rid of the I in the denominator. Okay, then you subtract them. Okay, so this is a long problem. Okay, so let's take a deep breath and do it. Okay, so 3 plus 2i over 1 minus 2i. How about you guys take turns to answer my question? Okay. Sarah, what do you multiply? Yes. Okay, that's the first fraction. Second fraction. Okay, let me learn your name. Here's a picture. Okay, let me see. Catherine, what do you multiply here? The conjugate of the denominator is? Yes, 3 minus I. So you see, we treat them differently because they have different denominator. Okay, so we treat them differently. We multiply by different conjugates. Okay, look at the first one. Let's see. Denise, right? Let's distribute. What's 3 times 1? 3 times 2i. 2i times 1. 2i times 2i. Yes. And next, Natalie, right? What is your denominator? Yes. Okay. Good. Let's continue. Let's see. Let's distribute the top of the second fraction. 2 times 3, 6. 2 times minus I. Negative 3i times 3. Negative 3i times negative I. Yes. Okay, and then Maddie. How about the denominator? Yes. Mm-hmm. Minus I squared. Yes, very good. Good, good, good. Okay, now let's simplify. Okay. Kayla, what is I squared? -1. Good. So, the top one, we have 3 minus 4. What's 3 minus 4? -1. And what is 6i plus 2i? 8i's, yes. 8i. Okay, good. And denominator, Lucas. What's your denominator?
3.
Mm-hmm. What did you say?
3.
3? Oh, okay. So because it's 1 minus, it becomes 4i squared. Ooh.
Oh wait, it'd be 5.
Oh yeah, it would be 5. So it's 1 minus 4 times -1. So 1 plus 4 is actually 5. Okay. It's actually 5. Okay, everybody? So it's 5 down there. And minus second fraction. Hunter?
No, Gabe.
Gate. Oh, Gabriel. Okay. Hey, so where's Hunter? Oh, okay. Maybe Hunter dropped our class. Okay, sorry. I should update my name. Okay, Gabe. Okay, Gabe. What's I squared? -1. So what's the constant term?
Or well, 3.
Yes, 6 minus 3 is 3. And then the I term is,
-11.
yeah, good. Okay, next, Jalen. What's the denominator? What's I squared? So this is 9 minus -1 is 10. Yes, it's 10. Is that okay, everybody? All right. Very good, very good. Okay. Now I would say split the real parts and the imaginary parts. Okay, let's split them. So if we split them, this is what? Negative 1/5, and then minus or plus? Yes, because this negative and this negative, when you distribute, it cancel, become plus 11/10i. Okay, everybody? You combine the constant, right? You combine the constants. What's the common denominator? 10. Right, everybody? How do you get 10? You multiply by 2. Let's do it slowly here. So add or subtract fractions. Make sure we have the common denominator. Okay? So this is minus 2/10, right, everybody? Minus 2/10. And then the other one is minus 3/10. Is that okay, everybody? You group them together. And then the I, you group them together. What's the common denominator? 10. So you multiply by 2. Okay, we multiply by 2. So 2 times 8 is what? 16 over 10i, and you want to add 11 over 10i. What's this? Minus 5 over 10 is minus 1/2, right? Okay, next. 11 plus 16, 27 over 10. Okay. So that's the end of this example. What time is it now? 3:01. Oh, we still have 6 minutes. We can do the next example together. Okay, yeah, our class ended at 3:07. And we're already one lecture behind. It's better to do more. Okay. So any questions about this problem? If you have two fractions, simplify each of them. And then you combine the like terms, then combine the real part and the imaginary part. Okay, everybody? All right. Example 9. Okay, example 9. We want to evaluate and simplify this. So what I would do is I would do the operation on the numerator first. Okay, let's do that. So do the operation of the numerator. Okay, Maxwell. So 1 times 2 is 2. 1 times negative 4i. 3i times 2. 3i times minus 4i. Bless you. I square. Yes. Okay, what's I square? Negative 1. Good. Next. Let's see. Do I have your face here? Ooh, I don't have your face. Okay. What's your name? Next. Olin? Olin. Yes. Okay, what is the numerator? Yes. 2i, and we usually put the 2i at the end, and then the constant on the left. Yeah, very good. It's 2, and then it's negative, minus 12 times minus 1 become positive 12. Right, everybody? So we get 14. Good. All right. Questions? Can we cancel the 2i? Yes? Yes? No. It's addition. We cannot cancel. Okay? If you can cancel the 2i, oh my gosh, just 14. This is a complex number. It's not equal to 14. Okay? All right. So now we need to get rid of the denominator. So what do we multiply by? Alicia? Right? Alicia? Yes. Okay, good. Next, David. Multiply the numerator. What do you get? Mm-hmm. You mean 20 AI? And then? 2i times 1 is 2i. 2i times minus 2i. Minus 2 times 2 is 4i squared. Right? Okay. Question. How about the denominator? 2i squared. Oh, but can you also tell me this is a 1 minus, what's 2I squared? 4 times -1. Ooh, which is 5. Yes. Is that okay, everybody? We actually seen this denominator before, so we know it's 5. Olivia, how about the upstairs? I squared is -1. So what do you get? Combine the constant term, you get 14, but then it becomes +4, right? 18. How many I? Yes. Are we done? Split them, right. So 26/5I. Okay, good. And then let's continue next class. So next class, please print out 3.2. Okay? All right. Also, maybe print out 3.3 as well. Maybe we can like faster. And so today we have a quiz. How do you do your quiz in Blackboard? Okay? And you start the quiz before 11 p.m. please. Okay. Bye. Sure.
Can you see if mine open it?
Yeah, quiz open
Yeah,
it.
so submission 2 and 3 have pictures. Because it will only let me upload like one, but I did them both on separate pages, so my graphs were bigger.
Oh, so it only allow you to upload one file?
Yeah.
Oh, okay. So in that case, you can combine into a PDF and then upload the PDF. Okay. Okay, let me see. All right. So, yeah, I would prefer you have all of them in one file.
That's what I went to do, but then at that time, a lot of time already passed. So I was like, okay, I'm just gonna turn it.
Oh, okay. So you have 3 attempts.
Yeah.
So the first one, nothing. Oh, thank you. Oh, sure. And second one image.
Mm-hmm.
Oh,
Yeah,
so
my graph.
that's your number 1. That's your number 2. Okay.
I think. Yeah.
Oh, okay.
So that's good then for now.
Yes.
Okay, next time I'll
Okay.
put it into one. I was already taking a lot of time.
Okay, okay. Thank you.